ACCU-FREEZE is the name of the brand?
Yep.
Okay. Cool. Yeah.
So this is all the components you'll see later.
What's the maximum size line you can do with something like this, with this particular size?
I think ours is to,
Maybe 6 inch?
no,
You'll do bigger
12
than that?
inch.
12 inch. Okay, that's impressive. Okay, good. Looks like they've got some things staged already for our demonstration here in just a little bit.
Took 5/16 copper and made a coil around the pipe where we're going to freeze it at. It's about 8 inches long on 3-inch pipe.
Thank you. All right, you're installing a
Thermocouple.
thermocouple, okay?
And it can't touch the pipe in order to read correctly.
It cannot?
Nope.
Okay.
So what we're going to do is we're going to try to get this reading as close to the exhaust. See, the liquid nitrogen will come in, go around the pipe, and we're going to try to get an accurate reading of what it's exiting.
Okay. You're gonna leave that little gap there.
Yep.
Okay.
Can't touch the copper either, obviously.
Okay. Understood. Okay, good deal.
So this is going to get down to negative, roughly 300 Fahrenheit. So you have to have some type of strap that won't give up, like black tape or zip ties. So
Okay.
we're going to get some type of nylon strap that'll withstand
Secure
that
that.
kind of
Okay.
degree.
Thank you.
This is a digital readout that takes thermocouples. And we're going to put it on both sides of the freeze, so we'll know the difference in the temperature of the building side and the side we're wanting to perform the work on.
Okay.
That way we know we're froze.
Okay, you were mentioning that something's on back order, that would be the blocks.
That would replace these copper coils.
Okay, so the copper coils can be used if you don't have the blocks.
Yep.
Okay, very well.
The only reason the blocks are better than the coil is if you're up in the air in a pipe rack and you can't coil around the pipe, those blocks just bolt together.
Makes sense. And this would be where the nitrogen will be introduced on this end.
Yep.
Okay, so you're doing the inlet temperature probe. Okay. Oh, there you go. Yeah. Okay. Securing the outlet temperature thermistor.
Don't break it. No, it's good. No, I'm good.
In order to get a reading,
Yeah, you got to make sure these thermocouples are twisted together. 'Cause
Okay.
if there isn't, then the current won't come back.
Okay.
The reading won't come back.
gotcha, okay?
So that, like that, is broke off, so it wouldn't be an accurate reading. So we'll have to strip it
I
back.
see, okay. I'm gonna be taking temperature readings from 3 separate points, and the one you're securing right now will be for,
It's the opposite side of the freeze.
okay. Oh, I got you. So, inlet side of the freeze, opposite side of the freeze, and the nitrogen outlet temperature.
This
Okay.
is what will control the throttle of the nitrogen.
Okay.
Exhaust. It's going to be the different readings on both sides. So you have, right now it's reading at 85 degrees. So that's about what we're going to start at. And we're going to try to bring it down to like 15 degrees. So,
Okay.
and then we have this reading here. So you have a T1 and a T2. So right now our T1 is 83 degrees. T2 is 84 degrees. So
We're pretty close.
really close.
And that's our, those are our,
Both sides.
both
Yep.
sides, gotcha.
Nitrogen on.
These are nitrogen on. Okay.
If you come here, we got a set point just like anything else. So right now I'm gonna put the set point on down. So say around 20 degrees Fahrenheit, and we're starting at 80.
Okay.
So this solenoid is attached to that module. So right now it's gonna really run hard until we start satisfying. It works just like HVAC.
And that's what we hear.
Yep. So,
Okay. Gotcha. Okay. Awesome.
we're gonna leave that off. I'm just gonna set it off.
Okay. So he's getting it set up. And he just turned it off for now. And we'll do the actual freezing, I guess, when John gets here, right?
Yeah, well, I'm actually gonna probably start it.
Are you gonna start it? Okay.
'Cause it takes about an hour.
Oh, it does. Okay. Of course, we have our pipe, our test pipe, and you've got it filled with a solid column of water to 100 psi-G. Is that correct?
Yep.
Okay. That looks like Tyler's gotten over his technical difficulties. So you figured out your technical difficulties? Good. Stop throttling back.
Stop throttling back.
That's our inlet, 59.7, and our outlet on the pipe is minus 15 already.
This side's 59 degrees,
Oh, okay.
this side's 75.
Oh, okay.
Got a lot more pop here.
I misunderstood the number. Oh, minus 15 there a minute ago, didn't I?
That's the combined of what we're trying to get it down to.
Oh, okay. Set point.
It doesn't So at this point, we got our set point at negative 135, and our exhaust is around 135. So this is trying to save on the amount of nitrogen we use. So once it satisfies, it dials down, and once it needs it, it gives it back.
Okay, so that explains our solenoid every now and then coming on, turning off and on, and the pattern that we see right now. Okay, interesting. So initially you were just giving it a quick chill down with constant flow.
Yep.
And you got to a certain point now where you can start conserving nitrogen.
Yep.
And let the machine, let your controller over here do what it's supposed to do.
Yep.
So basically that's the brains of your operation right there.
Yep.
Okay.
And you can run this down all the way to negative 400, negative 500 degrees.
Wow. Okay, awesome, dude. Yeah. Thank you very much. That's interesting. I was wondering earlier when I was here how long the tank would last with that, you know, the way I saw it earlier, just constantly blowing it out there. So yeah, okay. That's your pipe sizes and what now?
Your copper coil length.
Oh, how long the length has to be? Interesting.
And then
Okay.
these are just generic
Approximate
times.
Gotcha. Okay.
And then it tells you back here that freeze times may vary due to the working conditions. Anything in excess of 90°F, you add 15 minutes to the freeze time. In the table 1, every 4 degrees. So, yeah. And anything over 6, you add 15 minutes.
So it definitely is a smart device as far as utilizing the liquid nitrogen. Yeah. Did she fault on you again? No, I can't tell.